The definition of field extension is: suppose F is a field, then a field K is said to be an extension of F if F is a field of K. Now the degree of field extension: let K be an extension of a field F. The dimension of K as a vector space over F, the dimension of the vector space K of F, is called the degree of K over F. We shall always denote the degree of K over F by the degree of K over F. Finite field extension: let K be an extension of field F, then K is said to be a finite extension of F if the degree of K over F is finite. Thus, K is a finite extension of F if the vector space K, degree of K over F, is finite dimensional. Now, there is a theorem which is called transitivity theorem. So, the statement is: let L is a finite extension of K and K is finite extension of F. Then L is a finite extension of F. Moreover, the degree of L over F is equal to the degree of L over K, bracket the degree K over F. इसका proof है: since L is a finite extension of K and so the degree of L over K is finite, is that the degree of L over K is equal to M. We can say also K is a finite extension of F and so the degree of K over F is finite. The degree of K over F is equal to N. Say let V1, V2 and so on Vm be the basis of L over K. W1, W2 and so on Wn will be the basis of K over F. Let T belongs to L, then T is equal to K1 V1 plus K2 V2 plus so on plus Km Vm. इसको हमने क्वेश्चन नंबर 1 नाम दिया. Ki belongs to K. Since W1, W2 and so on Wn be the basis of K over F, and so K1 is equal to F11 W1 plus F12 W2 plus F13 W3 plus and so on F1n Wn. Similarly, K2 is equal to F21 W1 plus F22 W2 plus so on F2n Wn and so on. Km is equal to Fm1 W1 plus so on Fmn Wn. So Fij belongs to capital F. Substituting this value in equation number 1. So we get T is equal to F21 W1 plus so on F1n Wm V1 plus so on K M1 W1 plus Fm2 W2 plus so on Fmn Wn bracket Vm. So T is equal to F1 1 W1 V1 plus F1n Wn V1 plus so on Fm1 W1 Vm plus so on plus Fmn Wn Vm. Since T being an arbitrary element of K, so VIWJ span L over F. Now suppose that linear combination VIWJ. So F11 W1 V1 plus so on F1n Wn V1 plus so on plus Fm1 W1 Vm plus so on plus Fmn Wm Vm Wn is equal to 0. So F11 W1 plus so on plus F1n Wn V1 plus so on plus fm1 w1 plus so on fmn wn bracket vm is equal to 0, or we can write it as k1 v1 plus k2 v2 plus so on plus km vm is equal to 0. Now v1 v2 and so on vm are are linearly independent, so k1 is equal to k2 is equal to so on kn km is equal to 0. Here k1 is equal to f11 w1 plus f12 w2 plus so on plus f1 and wn is equal to 0. Similarly, so on km is equal to fm1 w1 plus so on plus fmn wn is equal to 0. Therefore, w1 w2 and so on wn are linearly independent, thus fij is equal to 0. Thus fij is equal to 0, then viwj is linearly independent. Dimension LF is equal to Mn, which is finite, so the degree of L over K is finite. L is finite extension of F. Moreover, dimension L over F is equal to Mn, which implies that the degree of L over F is equal to the degree of L over K, and the degree of F and the degree of K over F. It is the degree K over F. Now there is another theorem. L is finite extension of F and K is a subfield of L which contains F, then the field then the degree K over F is divisor of the degree L over K. Is that K the degree K over F is a divisor of the degree L over F. इसका प्रूफ देखते हैं. Let L, K, F be three fields such that L is a superset of K is a superset of F. Since L is finite extension of F, then the degree L over F is finite, say n. Let V1, V2 and so on Vn be the basis over F. Thus every element of L can be written as linear combination with V1, V2 and Vn over F. Since F is a subset of K, and so every element of L can be written as linear combination with V1, V2 and Vn over K, or L is generated by finite set and so must be finite dimensional. The degree L over K is finite, so the K over F is subspace of finite dimensional space L over K, so it is also finite. The degree K over F is finite by transitivity theorem. The degree L over F is equal to the degree L over K and the degree K over F. So we can write it, the degree L over K is equal to M and the degree L over F is equal to M bracket the degree K over F. So the degree K over F is a divisor of the degree L over F.